Hey there, y'all. Today we're going to look at Unit 3 review as we prepare for this Unit 3 test. And so we had 5 sections in Unit 3, and in those 5 sections we talked about Section 1, functions and their representations, Unit 2 on domain and range, Unit 3 on evaluating functions, Unit 4 on equations in two variables, and Unit 5 on function word problems. So let's first take a look at Unit 1, Section 1. We talked about how to determine if a relation is a function. And our other objective was to be able to convert relations between their different representations, including mapping diagrams, tables, graphs, and ordered pairs. And so let's take a look at some of the examples we saw there. And so remember a couple key definitions. A relation is any set of inputs and outputs. But a function is where a relation has one input with one output. I can't have one input with two different outputs to be a function. Remember, we're only going to have one. Remember, we talked about the different ways to represent those relations or functions, ordered pairs, tables, mapping diagrams, graphing it on the coordinate plane, and of course the equation of it. And so we talked about looking at different types and seeing if it was a function or not. And then we talked about how to translate it between different forms. We talked about in example 5 here, equations. Remember that there are two stipulations to an equation being a function. The equation needs to be solvable for y, and the y has an exponent of 1. And remember that inputting any x value will only give me one y value, not two or more separate y values. And so again, we looked at like an example like B, where if I put in one x value, we get 2 out because of the plus or minus. And remember to convert between the different forms. Remember that we want to know what our x's are and y's are, be able to put those in a table, put them on the graph, put it in a mapping diagram, and remember with mapping diagrams we don't repeat values, just like domain and range, and then we can also write it as a set of ordered pairs. Okay, so that was Section 1. In Section 2 we looked at domain and range, and our objective there was to identify the domain and range of relations and functions. And remember that domain is the complete set of x values. And we could have that as just a list like we see in example 1 here. Or if we go down and look at the graph of functions, we could have that as an interval, either written as an inequality or written in interval notation. And again, remember the range is the set of all the output values, the y values. And again, we can either have a list, or when we look at a graph, we could have an interval like negative infinity to positive infinity, or from negative 5 to positive 5. And again, we could have that as an inequality, negative 5 less than or equal to x, less than or equal to 5, or as interval notation, negative 5 to 5, both sides having brackets. And remember, both sides will have brackets there because they were equal to. If they're not equal to, then we're going to see that it would be a parenthesis, not a bracket. Okay, so that was Section 2 on domain and range. In Section 3, we talked about evaluating functions for a given variable, and what we looked at there was in 2 cases. First, function notation is not multiplication. This is a notation that tells us that we have a function whose label is the letter here, so in this case f, whose input is x. And then we could see like f of 3. So we have a function whose label is f, whose input we're replacing with 3. And again, we could have other variables involved to give us different names. So as we look at a function here, we're told to replace the x with 6. And so we have f of 6. We substitute that for the x, and then we will do our order of operations and simplify that down. So the order pair becomes 6, 19. Or if we have other types of functions, we can deal with those as well. And so when we look at a graph, remember that if I'm looking for f of a particular value, I'm going to go to x, come down, and see what the y value is there. So like f of 3, I go to x being 3, my y value is 7. So f of 3 is equal to 7. We can do this for any graph. It could be individual points. It could be a line like this. It could be some type of curve. It doesn't matter. We can evaluate a function given the graph, or we can evaluate the function given the equation. So in Section 4 and Section 5, these 2 sections are basically the same. Section 4, we just didn't talk about word problems, and in Section 5, we did introduce those word problems. And so Section 4, exploring the relationship between the solutions of an equation in two variables and its graph. Remember that when we have an equation in two variables, there will be infinitely many solutions. And remember that a solution of an equation in two variables is any ordered pair that makes that statement true. And so remember that we talked about how we can test if a particular ordered pair is a solution. And so we plug it in for the x and the y and see if the left side is equal to the right. And if it works, then it's a solution. And if it doesn't work, it's not a solution. Or we could be asked to graph it, and that's where we need to pick particular values of x to solve for the y. And so like here we have y is equal to x plus 2. Everywhere we see the x, we're going to substitute in our x values, get our y values, and then we'll have our ordered pairs to plot on the coordinate plane. Okay? Remember, if our function's not solved for y, so if we had like x plus 3y is equal to 9, we would need to solve this equation for y so that we can use the table. And so our two steps, subtract the x from both sides, and we get 3y is equal to 9 minus x. And then we can divide both sides by the 3. And so we get y is equal to 9 minus x all over 3. Or we could simplify this a little bit and write it as y is equal to 3 minus 1/3 x. Either of those would be acceptable. And we could plug in values for x to find values of y. And again, that would allow us to be able to use our table to get those points. Remember that when we graph lines, we need at least 3 points. 2 gets us a line, but 3 verifies that our line is actually in the right spot. We haven't made an error if all 3 points make a nice, pretty line. And so section 5, we talk about those word problems. And remember, the key thing to those word problems is understanding what's going to go where, and understanding that when we have our x and y, it's not just x and y here, it is that x is something. And in like this example, x was the number of guests, or y was the total cost in dollars. And remember, we want to make our graph large enough that we cover the information we're finding. We don't want our graph to just go off and be unable to plot some of those points. Okay, so that is the Unit 3 review. If you've got questions, put them into the Google form so that way we can discuss them in class. And again, I hope y'all have a great one, and I'll catch y'all next time.